85% of catastrophic drivetrain failures do not start with a loud bang, a cloud of smoke, or a flashing check engine light. They start with a whisper, a sound so faint, so completely unthreatening that you will naturally tune it out. Your passenger will not hear it. Your radio will easily drown it out. And the multi-million-dollar diagnostic software at your local dealership will completely ignore it. This single acoustic blind spot is costing modern truck owners an average of $3,000 a change out of their own pockets every single day. Why? Because you have been conditioned to trust a digital dashboard over your own physical senses. The system wants you to wait for the light. I am here to tell you that by the time the light comes on, the financial damage is already done. You are no longer paying for a preventative fix. You are paying the full extortion rate for a mechanical resurrection. Let me take you back to March 4th, 2025. It was a Tuesday, about 20 minutes before I was going to throw the deadbolts and lock up the shop for the night. The rain was hitting the metal roof, the air was cold, and I was already wiping the grease off my hands. That is exactly when a clean white Tundra rolled up to my bay. The driver got out, and before he even said hello, he started apologizing. He told me it was probably nothing. He said his wife had spent the entire weekend telling him he was being completely paranoid. He explained there was just this tiny, faint whirring sound when he started the truck cold first thing in the morning. It lasted maybe 20 or 30 seconds, vanished into thin air, and never came back for the rest of the day. The truck drove beautifully. It pulled his trailer without a hiccup. He admitted to me he almost did not bring it in at all, because he felt foolish wasting a technician's time with a ghost story. I did not laugh. I did not tell him he was crazy. I asked him to shut the ignition off, let the fluid settle for a few minutes, and then crank it again while I stood with the hood up. The second that starter motor engaged and the V8 fired to life, I caught it. It was a soft, high-pitched mechanical whir. It sounded almost like a miniature vacuum cleaner spinning up somewhere deep behind the intake manifold, right against the firewall. The owner looked at me and smiled. He looked incredibly relieved, like he was waiting for me to slap him on the back and tell him it was just a normal characteristic of the truck. I did not smile back, because that exact sound was the early acoustic warning for a highly specific mechanical failure. Left alone for another month or two, that quiet little whir was guaranteed to drop his truck into a dangerous limp mode on a fast-moving highway and present him with a dealer service invoice north of $3,000. Today, I am breaking the industry silence. I am going to walk you through 5 specific, highly deceptive noises that modern trucks and SUVs make that almost every single driver ignores. They ignore them because they are quiet. They ignore them because they come and go with the weather. They ignore them because the vehicle still accelerates, brakes, and handles perfectly. But make no mistake, every single one of these sounds is your vehicle quietly screaming that an expensive component is currently executing its final countdown. Here is the fundamental truth the corporate service departments never want you to understand. These subtle noises are not the failure event. They are your window of opportunity before the failure event. If you catch the defect while it is still just an acoustic anomaly, you are looking at a tiny fraction of the repair cost. You are buying a cheap component, a simple seal, or a basic fluid flush. But if you wait until the dashboard lights up like a Christmas tree and the vehicle loses power in the middle of traffic, the window is slammed shut. You are now paying full retail price for major components, heavy labor hours, and shop supplies. Why is this diagnostic gap so incredibly common on these specific platforms? Is because these vehicles are engineered almost too well for their own good. The drivetrains are massively overbuilt. The mechanical tolerances are robust, and the onboard computers are programmed to be incredibly patient. A modern truck will keep running smoothly, keep its idle perfectly stable, and keep the check engine light dark long after a vital internal component has begun to physically disintegrate. The machine masks its own suffering. Therefore, the only thing that tells you the unvarnished truth early enough to save your wallet is sound. Your ears are the most sensitive, accurate, and completely free diagnostic tool you will ever own. Yet, almost nobody uses them until the tow truck is already on its way, Let us start exposing the corporate playbook. Number 1 on the list is the brief, metallic rattle on a cold startup that completely disappears in a second or two. This is hands down the most misdiagnosed sound in the entire automotive world. It sounds exactly like someone took a short length of bicycle chain, dropped it into an empty metal coffee can, and gave it a violent shake for a split second. You turn the key on a freezing morning, you hear that harsh, dry rattle, and then instant silence. The engine immediately settles into a smooth, quiet idle. There is no roughness. There is no smoke. There is no warning light. Naturally, drivers tell themselves it is nothing. They think it is just the oil pump waking up, or the cold metal expanding, or just a quirky habit of the machine. They are wrong. On a massive volume of modern engines, especially the inline four-cylinders found in mid-sized trucks and crossovers, and the older V6 blocks, that specific 1-second rattle is the death rattle of your VVTi actuator. That is the variable valve timing gear bolted directly to the nose of your camshaft. Inside that highly complex gear sits a tiny, precision-machined, spring-loaded steel locking pin. When you turn your engine off and walk away, the engine oil naturally drains out of the top cylinder head assembly and sinks back down into the pan overnight. That tiny pin has one job. It must mechanically lock the internal gear mechanism in place so it cannot move until fresh oil pressure arrives the next morning. But as the miles pile up, that locking pin pocket begins to oval out and wear down. It loses its tight seal. The next morning, you crank the engine. The top of the motor is completely dry. Because that pin failed to lock the mechanism, the massive rotational forces of the engine cause the internal elements of the gear to violently slam back and forth against its own aluminum housing. It clatters uncontrollably until the oil pump finally pushes fresh fluid up to the cylinder head, fills the chambers, and hydraulically cushions the impact. That takes about 1.5 seconds. Here is what the manufacturer does not want to advertise to you. They knew about this. They issued technical service bulletins regarding this exact acoustic signature. Yet, if you walk into a service drive and describe it casually, a hurried service writer will often tell you to just keep driving it until a code sets. Do you know why that is terrible advice? Because that daily, high-velocity metal hammering does not stay confined to the gear. Every single morning that the actuator slams around, it sends a high-frequency shock wave directly down the timing chain. It slowly stretches the steel links. It shaves microscopic layers of plastic off your timing chain guides. It beats up the tensioner arm. If you catch it early, when it is just a brief morning rattle, you are replacing a single actuator gear. It is an accessible, straightforward fix. But if you accept that that is normal brush off and wait until the worn gear completely rounds off or snaps the internal lock, the timing chain jumps a tooth. Now, the plastic guides shatter, dropping debris directly into your oil pickup tube. Suddenly, your simple top-end fix has transformed into a catastrophic engine teardown. On a V6 platform, the clearances are so tight that the entire engine assembly practically has to be unbolted and dropped completely out of the frame just to remove the front timing cover. The invoice mutates from a minor annoyance into a multi-thousand-dollar structural overhaul. The sound was exactly the same on day one as it was on the day it broke down. The only thing that changed was how long the driver chose to ignore the warning. Which brings us directly back to the mystery that rolled into my shop on March 4th. That soft 20-second morning whir on the V8 engine family. This is the second acoustic signature you cannot afford to look past, and it targets the largest, most legendary power plants on the road. If you are running a heavy-duty half-ton truck, a full-sized SUV, or a luxury variant carrying a 4.6 or 5.7-liter V8, you need to listen closely to this specific sequence. The system responsible for this noise is called the secondary air injection system. It is a complex emissions setup consisting of powerful electric air pumps and vacuum-operated switching valves. When the engine block is completely cold, the fuel injection system runs incredibly rich to keep the engine from stalling. To prevent that raw, unburnt fuel from destroying the expensive catalytic converters, these electric pumps engage immediately upon startup. They act like a high-powered set of lungs, forcing fresh atmospheric oxygen directly into the exhaust manifolds to create a secondary burn, rapidly heating the system to operational temperature. That is the whirring noise. When the system is brand new and healthy, it sounds like a smooth, controlled, aerodynamic rushing of air. It runs for precisely 30 seconds. The computer checks its boxes, the valves shut, the pumps power down, and the truck behaves normally for the rest of the day. But here is the engineering flaw they will never print in the owner's manual. The system lives in an environment constantly subjected to extreme temperature swings. As the exhaust cools down after a long drive, moisture condensation naturally forms inside the tubes. Because of where these switching valves are physically located on the block, that moisture has nowhere to go. It pools inside the valve assemblies. Over time, that water causes the internal steel shafts to rust, corrode, and pit. The rubber diaphragms dry out. Simultaneously, the electric air pumps start sucking in ambient debris, slowly degrading their internal fans. One morning, you will turn the key, and that smooth, healthy whir will sound different. It will sound slightly louder or rougher, or it will cut in and out erratically. That change in pitch is the exact moment the system is telling you that the valves are binding, or the pump bearings are actively seizing up. If you ignore that subtle shift in tone, the trap snaps shut. The valve will eventually stick wide open. The next time you hit the highway, scorching hot exhaust gas will travel backwards through the open valve, rushing directly into the plastic electric air pump. It melts the housing, destroys the wiring harness, and sends a massive electrical spike straight back to the engine control module. Instantly, your vehicle reacts to protect itself. The dashboard erupts. The check engine light burns solid, the stability control light deactivates, and the four-wheel drive low indicator starts flashing rapidly. The computer completely panics and drops the vehicle into a severe limp mode. The electronic throttle body refuses to open past a fraction of an inch. You can put the gas pedal completely to the floorboards, and the engine will stubbornly refuse to cross 2,000 RPM. Imagine experiencing that sudden, unmediated drop in power while you are running 70 miles per hour in the fast lane of a packed interstate with a loaded trailer hitched to your bumper. It is not just an inconvenient mechanical failure, it is a genuinely terrifying safety hazard. And when you finally manage to limp the vehicle onto the dealer's lot, the service writer is going to hand you a quote that will make your stomach drop. Because reaching those pumps and valves requires completely stripping the top half of the engine, removing the entire intake manifold structure, and replacing every single scorched component with updated factory parts. They will calmly explain that the standard book time for the labor alone runs into the double digits. The manufacturer was well aware of this systemic vulnerability. They quietly extended the factory warranty coverage on these specific pumps and valves to 10 years or 150,000 miles for certain production runs. But here's the catch the system counts on. Time always wins. The vast majority of these legendary V8 trucks have now crossed over that age and mileage threshold. The extended safety net is gone. If that system fails today, you are completely on your own, facing the full financial weight of a design flaw that was set in stone over a decade ago. That is exactly why you have to catch it while it is still just a faint, slightly altered whir in the morning. That sound is your absolute final opportunity to inspect the system. Check your vehicle identification number for any weird overlapping coverage campaigns, or look into highly effective, completely legal aftermarket bypass solutions before the physical failure locks your vehicle down and forces your hand. But the engine bay is not the only place where these expensive acoustic warnings hide. As we move down the drivetrain, the noises become even more deceptive, shifting from the sharp clatter of the engine to the deep, hypnotic drones of the chassis. And the next noise on our list is perhaps the sneakiest financial trap of them all, because it actively uses your own vehicle's configuration to mask its approach, waiting for you to blame everything else before you finally realize what you are actually up against. Here is the fix most dealerships will never mention to you. When that secondary air injection system fails, the corporate playbook says you must replace the entire system with identical factory parts at an astronomical markup. They want to tear down the top of your engine, drop in the same flawed valve designs, and charge you for 12 hours of high-rate labor. What they will not tell you is that you do not have to play their game. There is a far more permanent, elegant, and radically cheaper solution that cuts the dealer completely out of the equation. You can physically isolate the failed valves and electronically reprogram how the computer monitors the system, solving the issue for a tiny fraction of the cost. Using basic tools in your own driveway, let me explain exactly how this works in the real world. A regular customer of mine, let us call him a classic weekend warrior with a high-mileage half-ton truck, came into the shop completely defeated. He had already been to the local franchise dealer after his truck dropped into limp mode on the way to a job site. They handed him a written estimate for $3,200 to replace both air pumps and the entire switching valve assembly. The truck was worth maybe $12,000 total. He was ready to trade it in at a massive loss just to escape the bill. I told him to breathe. I brought the truck into my bay, popped the hood, and showed him what was actually going on under the plastic engine cover. We did not touch the intake manifold. We did not tear down the top end of the motor. Instead, we installed a specialized electronic bypass kit coupled with mechanical block-off plates. Total cost for the parts was under $300. Total time on the clock was less than 45 minutes. He drove out of my shop with full engine power restored, the dashboard completely clear, and nearly $3,000 kept safely in his bank account. Here is the step-by-step breakdown of how you execute this fix yourself. You do not need a professional hydraulic lift, and you do not need an advanced automotive engineering degree. You need a standard socket set, a couple of basic hand tools, and about an hour of uninterrupted time on a Saturday morning. First, you must address the physical side of the failure. The problem is that the factory switching valves are stuck open, allowing hot, highly corrosive exhaust gas to flow backward toward the air pumps. To stop this permanently, you install mechanical block-off plates. These are small, precision-cut plates made of heavy-gauge stainless steel or aluminum. You locate the factory air injection tubes where they bolt onto the exhaust manifolds near the back of the engine bay. Using a 10mm socket, you loosen the factory nuts, slip the block-off plates directly between the flange and the pipe, and torque the fasteners back down. This creates an impenetrable physical barrier. Exhaust gases can never travel backward again, and moisture can no longer pool inside the sensitive mechanical components. Second, you must address the electronic side of the equation. Even with the physical plates installed, the engine control module will immediately notice that air is not flowing when the truck is started cold. It will instantly throw a code and trigger limp mode. To prevent this, you install an electronic bypass module. This is a compact, completely plug-and-play wiring harness that intercepts the signal between the engine coolant temperature sensor and the intake air temperature sensor. You simply locate the factory sensor plugs, usually right near the front air intake tube or the thermostat housing, disconnect the factory harness, and snap the bypass module directly inline. No cutting wires, no splicing, and no permanent modifications to the vehicle's factory electrical system. When you turn the key on a cold morning, this clever little module performs a bit of electronic magic. It briefly alters the temperature signal sent to the engine control computer for exactly 30 seconds. It convinces the computer that the ambient air temperature is just warm enough that the secondary air injection system does not need to activate at all. Because the computer thinks the system isn't required for that specific start cycle, it never commands the air pumps to spin up, and it never opens the switching valves. After 30 seconds pass, the module seamlessly switches off, returning the temperature signals to 100% factory accuracy, so the engine runs, fuels, and adapts normally for the rest of your drive. The system is permanently deactivated, yet the computer remains completely happy. No codes, no warning lights, and no limp mode. Let us look at the raw math of this repair versus the dealer route, so you can see the scale of the system you are fighting against. The factory replacement parts alone, 2 electric air pumps and 2 switching valves, regularly retail for anywhere between $1,200 and $1,800, depending on the specific engine code, because the corporate engineers buried these components directly underneath the intake manifold runner assembly on the V8 engine family. The official labor guide specifies between 7 and 10 hours of highly specialized shop time just to perform the swap. At modern shop rates that easily hover around $150 to $200 an hour, the labor cost alone eclipses the value of the components. Conversely, the bypass method requires exactly 0 factory replacement parts. The kit consists of 2 metal plates and a small sealed electronic harness. You are paying for engineered intelligence, not heavy cast iron or fragile electric motors. Because you never have to unbolt the intake manifold, disturb the fuel rails, or drain the cooling system, the risk of creating a secondary leak or stripping an aluminum thread in the cylinder head drops to 0. You bypass the labor, you bypass the parts markup, and you bypass the inherent design flaw permanently. However, you must be extremely cautious, because this level of simplicity breeds a lot of dangerous misconceptions and amateur mistakes online. The biggest mistake I see DIY drivers make is buying cheap, unverified counterfeit bypass kits from fly-by-night online sellers. These cut-rate kits often use low-grade resistors that do not shut off after the initial 30-second startup window. They continuously spoof the engine temperature signal to the computer all day long. When your engine control module constantly thinks the engine is running cold, it will aggressively dump excess fuel into the cylinders. Your fuel economy will absolutely plummet. Your spark plugs will quickly foul out with heavy carbon deposits, and you will eventually melt the expensive core of your actual catalytic converters from the raw fuel washing down the tailpipe. You must ensure you are using a dynamic, smart module that only operates during the initial start sequence and then completely drops out of the circuit. The second major misconception revolves around the physical block-off plates themselves. A lot of forum threads claim you can just plug in the electronic module and completely ignore the mechanical plates. That is an absolute lie that will leave you stranded. If your factory switching valve has already failed in the physically open position, installing the electronic module will stop the computer from checking the system, but it will not stop the laws of physics. Hot exhaust gas will continue to push through that open valve, eventually melting the rubber hoses, filling the engine bay with toxic exhaust fumes, and creating a massive, noisy exhaust leak that sounds like a broken tractor. The physical block and the electronic bypass are a matched set. You cannot do one without the other. Finally, you need to understand the legal and functional parameters of this fix. This modification is designed strictly for off-road, racing, or legal fleet vehicles, as altering any factory emissions component can run afoul of local state inspections depending entirely on where you live. But from a purely mechanical standpoint, catching that faint morning whir early and utilizing a permanent isolation strategy is the single smartest way to protect your vehicle's engine from its own self-destructive design. Now that you know exactly how to handle the engine bay, we need to shift our focus further down the truck's spine. Because the third noise on our list, that low, rhythmic highway howl that completely changes character the instant you lift your foot off the accelerator pedal, is waiting for you. And if you think a simple fluid change is always enough to save a singing rear differential, you are missing the most critical mechanical warning sign of them all. When you step outside the corporate maintenance loop and address these flaws permanently, you are not just dodging a single massive repair bill. You are fundamentally changing the lifespan and operational efficiency of your entire vehicle. By isolating a failure-prone system like the secondary air injection loops or catching a drive variable valve timing actuator before it stretches your timing chains, you preserve the structural integrity of the base engine block for hundreds of thousands of miles. You achieve absolute mechanical predictability. You gain the immense peace of mind that comes from knowing your truck will not suddenly drop power on a dark highway, 300 miles from home, with your family in the cab. You regain control over your machine, ensuring it operates on your terms and your schedule, not the dealership's service calendar. To truly maximize this mechanical advantage and ensure your truck reaches that legendary 500,000-mile mark, you must pair these physical fixes with targeted, uncompromising maintenance habits. The absolute first habit you need to cultivate revolves around your oil management strategy. The corporate marketing departments love to advertise 10,000-mile oil change intervals because it lowers the projected cost of ownership on paper during the initial warranty window. Do not fall for it. On modern engines with highly complex hydraulic valve trains and tight oil passages, extended intervals are pure poison. You need to commit to a strict 5,000-mile or 6-month oil change interval using premium full synthetic oil and a high-efficiency factory filter. Clean oil is the lifeblood of your timing system. It keeps the microscopic passages inside your variable valve timing gears completely clear of varnish and carbon sludge, preventing the hydraulic locking pins from sticking or wearing prematurely. Think of it as cheap insurance. 20 oil changes will cost you less than a single timing chain teardown at a major shop. The second complimentary check focuses directly on your underhood inspections. Once every single month, when the truck is completely cold and parked on a level surface, pop the hood and visually trace your lines. Look at the cooling system connectors. Inspect the wiring harnesses for signs of heat stress or brittle insulation, and check your fluid levels manually. Do not trust the digital dipsticks or the low fluid warning lights on the dashboard. By the time a digital sensor registers a critical drop in fluid level or pressure, the mechanical components have already been operating in a compromised state for weeks. Physical verification with your own eyes will catch a weeping water pump gasket or a pinhole radiator leak when it is still a $20 fix, long before it becomes an overheating event that warps your cylinder heads, however. As a mentor who has spent decades analyzing these machines, I must be completely transparent with you about the potential trade-offs and realities of taking vehicle maintenance into your own hands. Every single engineering choice is a compromise, and modifying or isolating a system always carries a minor counterweight. When you deploy a permanent bypass strategy on a secondary emissions loop, your truck will naturally take slightly longer to bring its catalytic converters up to full operational temperature on freezing mornings. From a purely functional standpoint, this does not alter your engine performance, your throttle response, or your daily drivability one bit. But from a strict tailpipe emissions perspective, during the first 60 seconds of a cold start, the vehicle will run slightly richer than the factory originally intended. You must also recognize that becoming an empowered car owner requires a shift in your psychological relationship with your vehicle. You can no longer afford to be a passive driver who simply turns the key and tunes out the world. You have to actively listen to the machine. You have to learn its baseline rhythms so that when a new hum, a subtle vibration, or a brief rattle introduces itself, you register it instantly. Some drivers find this extra level of mindfulness annoying. They prefer the blissful ignorance of driving a vehicle until the wheels fall off and then complaining about the unreliability of the brand. But for a true enthusiast, this connection to the machine is not a burden. It is a badge of honor. It is the exact trait that separates a true mechanic from a mere operator. Look at the big picture here. The modern automotive ecosystem is increasingly designed to keep you completely dependent on proprietary software, locked factory service manuals, and specialized corporate diagnostic tools. They want to turn the space under your hood into a black box that you are forbidden to open or understand. They want you to feel helpless the moment a warning indicator illuminates, so that you will submissively hand over your credit card and accept whatever inflated narrative the service advisor feeds you across the desk by educating your ears. By learning to decode the faint whispers of failing steel and shifting fluids, and by implementing permanent common-sense fixes, you are actively rebelling against that system. You are proving that a dedicated owner with a basic set of hand tools and the right knowledge can still outsmart a multi-billion-dollar corporate engineering department. You are claiming true ownership of the asset you paid hard-earned money to put in your driveway. Tomorrow morning, when you step out to your vehicle, do not just jump in, blast the radio, and rush out into traffic. Take that brief 30-second pause. Roll the windows down, turn the climate control fan completely off, and turn the key. Listen to the starter engagement. Listen to the oil pressure rise. Listen to the way the pulleys spin up and the exhaust note settles. Learn the vocabulary of your specific engine. Because the most valuable tool in your entire garage is not an expensive scan tool, a massive rolling toolbox, or a pneumatic impact wrench. It is your own focused attention. Stay ahead of the failure window. Trust what your physical senses are telling you, and keep your truck exactly where it belongs, out on the open road, performing flawlessly, and completely out of the dealership's service bays.